Hello learners, welcome to this course on Embedded System Design using PIC16F877 microcontroller. In this tutorial, I will be discussing about on how to perform multiprocessor communication. So in a multiprocessor communication, I am going to take two controllers, PIC16F877 microcontrollers. So one I am going to use it as a transmitter and another one I am going to use it as a receiver. So this microcontroller PIC16F877 is going to be used as a transmitter and another PIC16F877 microcontroller is going to be used as a receiver. And I am going to do a data transmission using UART protocol. So UART is a universal asynchronous receiver transmitter protocol where we can transmit the data in a serial fashion. So in the transmitter, I am going to connect a LM35 temperature sensor, and this sensing value will be converted into a digital value by this transmitter microcontroller, and it will be transmitted using a UART protocol connected to this RC6 and RC7. And on the receiving side, I am going to receive this data from a receiver microcontroller and trying to display it on the LCD, 16x2 LCD. So a temperature measurement is done on one side and its display is on the other side. So if I see a temperature sensor LM35, it has three leads. So the first lead is a supply voltage where we can supply about 4 volt to 20 volt, and the third lead will be a ground line, and the center lead will give the voltage corresponding to the temperature. So if I see the resolution of this temperature sensor, it is about 10 millivolt per degree centigrade. For example, if the room temperature is 30 degrees, then the voltage coming out of this pin number 2 will be 30 into 10 millivolt, which will be 300 millivolt. So this sensor can measure from minus 55 degrees centigrade to 150 degrees centigrade. So it has an accuracy of about 0.5 degrees centigrade at 25 degrees centigrade. So we are going to use this sensor on the transmitter side, and it is going to be connected to the AN0 pin of your microcontroller. So the microcontroller supports 8 channel, and in one of the channel AN0 we are going to use this temperature sensor. So the inbuilt ADC in your PIC16F877 is a 10-bit ADC which gives a 10-bit result. So the 10-bit result will be converted into a voltage, and then it will be converted into a temperature, and the temperature value will be sent through this UART lines, transmitter line and receiver line. So the transmitter line is multiplexed with RC6 and receiver line is multiplexed with RC7. So upon the receiving side, we will get the data again using the UART protocol. Now you can see on the receiving side, the receiver pin, which is RC7 or receiver line, is connected to the transmitter line of your transmitter microcontroller. Same way, the transmitter pin of the receiving side is connected to the receiving pin of your transmitter microcontroller. So it will be like a cross connection. So a transmitter from one side, it will go to the receiver of the another side. A receiver from one side, it will go to the transmitter of the other side. And after receiving this data using the microcontroller, we try to put it onto the LCD. Now let us look at the data format, UART data format. So here we try to send the data in terms of a packets. So packet in the sense, it has a logic 0 and logic 1. So it has a start bit which is represented by a logic high to low. Transition is considered as a start bit. Then comes the data bits. So the data bits can be varying from 5 bits to 8 bits. Here for an example, I have given it as a 7-bit data. So usually the LSB data will come first and finally your MSB data. So after this MSB data, we have a parity bit. So this parity can be an even parity or an odd parity. So usually for an even parity, it will be represented by bit 0. If it is for an odd parity, it will be represented by bit 1. Then we have a stop bit which goes from 0 to 1. So here the logic 0 is represented by 0 volt, logic 1 is represented by 5 volt. Since both the microcontrollers are going to work with TTL logic, we no need to put a MAX 232 IC here. So we can directly connect the UART of transmitter microcontroller to the UART of receiver microcontroller. So for example, here you can see, if I want to transmit the data M, capital M, its ASCII value is given as 1001101. So if I count the number of ones here, it is even number, 4 ones are there, so it is a even parity. Then how the signaling will be there? First there will be a start bit, high to low transition. Then comes your LSB bit. So LSB bit is 1. Then subsequently the remaining bits will come. Then finally your MSB part. And then a parity bit, and finally a stop bit. So this is how the transmitter and receiver communicates with each other through UART protocol. So now let us go and build the circuit using Proteus 8 professional software. So here you can see we have a transmitter microcontroller and a receiver microcontroller. So the transmitter microcontroller and receiver microcontroller are connected with the oscillator circuit. So here I have connected 20 MHz crystal oscillator on both sides. And we have also connected the reset circuit here on both sides. So this is a reset circuit connected to your microcontrollers. Then I have connected a temperature sensor, LM35 temperature sensor. So pin number 1 is connected to supply, pin number 3 is connected to ground, and pin number 2 goes to the A and 0 pin of your transmitter microcontroller. Then after conversion process, the data will be sent through the UART protocol through this RC6 and RC7. So here you can see the transmitter line from the transmitter microcontroller goes to the receiver line of the receiver microcontroller. Same way, receiver line of the transmitter microcontroller goes to the transmitter line of the receiver microcontroller. So it's a cross connection. So transmitter on one side, it goes to the receiver on the other side. Receiver on the one side, it goes to the transmitter on the other side. So upon receiving the data by the receiver microcontroller, the data will be put onto the LCD. So here we have connected a 16x2 LCD, which is connected in a 4-bit fashion. So here B4 to B7 port lines are connected to D4 to D7. Remaining D0 to D3 is grounded. Since we are going to use a 4-bit mode, only 4 data lines are used. And same way RS, register select line, goes to the RB2 line, enable line goes to the RB3 line. At RW bar, we have grounded it, indicating that we are going to do only write operation. Then we have power supply lines. VSS is connected to ground, VDD is connected to supply, and VEE is for contrast adjustment. So this contrast adjustment, usually it will be connected with the potentiometer. Here I have connected it to the ground line. Indicates we are going to have a high contrast. So this completes our hardware circuit building. Now let us go and write an embedded C program using Micro C Pro for PIC compiler. So now I am going to open the project transmitter. So we have to write 2 codes, one for the transmitter side, another for the receiver side. So first let me explain the transmitter code. So you can see we have set the microcontroller as 16F877 and the oscillator frequency is 20 MHz. So first I declare few variables like temp hex, temp volt, and some CH1, CH2, CH3 as a character variable. In the main program, I start with intcon equal to 0, which means this is an interrupt control register. So we are not going to use any interrupts here. So I am going to disable everything. So if I put 0 here to the register, then all the interrupts will be disabled. Then in port C, RC7 and RC6 are the receiver and transmitter line. So RC7 is your receiver line, RC6 is your transmitter line. So we need to set the data direction for this lines. Since it is a receiver line, RC7 is configured as a receiver RC6 is configured as a transmitter. By putting 1 to this register, it will be configured as receiver. By putting 0, it will be configured as a transmitter. So here TRISC is a data direction register. So we specify a value of 0x80. Then ADCON1 is used for the channel selection of your ADC. So it supports 8 channels. We have connected our sensor to A and 0. So in order to enable it, I have given the value as 80. Then we need to set the input for your port A and 0. So for that I set it as 0xFF. So thereby the port A will be configured as an input port. Then we initialize the ADC so that the ADC conversion will happen with default setting, that is RC clock will be used. Then we initialize the UART with a baud rate of 9600. So 9600 bits per second the data will be transmitted. Wait for some time for the UART to get initialized, then go to the main while loop. So in a while loop, I am going to read the data from channel 0. So from A and 0, we are trying to read the data. After the conversion process, the 10-bit result will go to the temp_x. So since it is a 10-bit value, 2 power 10 is nothing but 1024. So it starts with 0, it ends at 1023. So depending upon the voltage given to the A and 0 pin, a value will be obtained between 0 to 1023. So this is a hexadecimal value. We need to convert this value into voltage. In order to convert it into voltage, I multiply this hexadecimal value with the resolution of your ADC. So resolution of your ADC is 4.88 millivolt. How we get this 4.88 millivolt is, if I use a reference voltage of 5 volt, which is nothing but 5000 millivolt, divided by 2 power n minus 1, where n is the type of ADC. So here we have a 10-bit ADC, so it will be 2 power 10 minus 1. So 2 power 10 is 1024, 1024 minus 1, it is 1023. So we divide 5000 divided by 1023, it gives about to be 4.88 millivolt. So this is the resolution of your ADC, which is the smallest voltage change measured by the ADC. So when we multiply this hexadecimal value with the resolution of the ADC, we get the voltage. Once I obtain the voltage, I want to convert this voltage into a string value. In order to do that, I am going to separate this each character. For example, let us take my temperature is 32.3 degree centigrade. Room temperature is 32.3 degree centigrade. So what will be the voltage measured? We know that for LM35, 10 millivolt variation for every degree centigrade. So we will get 323 millivolt. Now I want to separate each character. So 3 separately I have to take, 2 separately I have to take, and another 3 I have to take it separately. So in order to do that, what I do is, this 323 I am going to divide it by 100. Okay, so 323 is available in temp_volt. So this 323 I am going to divide it by 100. Thereby I get 3 quotient value. So this 3 I am going to put it onto a variable called as CH1. Same way, next 323 divided by 10. So divided by 10 in the sense I will get 32 quotient value. Then I am going to do a mod of 10. So mod in the sense remainder value will be obtained. So 32 mod 10 I will get 2. So the second character in the temperature we try to get it. Then I try to put this second character onto CH2. Same way I get the third character. So 323 mod 10. So we will get the remainder value which is 3. Then I try to put this 3 onto CH3. So I have got all the 3 characters, and this 3 characters I need to convert it into a string and send it through UART. So I am going to use only 2 characters, CH1 and CH2. I am going to leave the character after the decimal point, because our temperature sensor resolution is only 1 degree. 0.5 degree at 25 degrees centigrade. So I'm going to approximate it to real numbers, integer numbers. So I'm going to use uart underscore write. So ch1, which is nothing but 3, I'm going to add it with 48 for converting it into a ASCII value. So here if I see the ASCII chart, you can see for 3, my ASCII value is 51, which means 48 plus 3, you will get 51. So the 51 will be sent to your receiver side. Same with ch2 plus 48, we will send the string value of 2 to the receiver side. Then I wait for 2 seconds. After 2 seconds, again I will try to read the sensor data, convert into hexadecimal value. From hexadecimal value, convert it into a voltage, separate the characters and send the data to the receiver side. So this completes the transmitter part of your microcontroller. So let us compile this program. Now let us go and build the receiver circuit. First let me close this project, open the receiver program. Now first in the receiver side, I am going to initialize the LCD. So LCD RS line is connected to B2, enable line is connected to B3, D4 of LCD is connected to B4, D5 of LCD is connected to B5, D6 of LCD is connected to B6, D7 of LCD is connected to B7. So we connect the LCD in a 4-bit mode and the corresponding data direction registers we are trying to set it. For LCD RS, press B2, enable, press B3, D4, B4, D5, B5, D6, B6, D7, B7. So the corresponding data direction registers are set. Since I am going to receive only 2 characters, I declare an array with 2 characters, which is receive of 2. Then I am going to use a variable I. Then in the main program, as usual here also, we try to disable the interrupts. So intcon is an interrupt control register. We try to disable the interrupts. Since we are using a UART, again I need to set the receiver line to be input and transmitter line to be output. So RC7 is configured as input by setting it to 1. RC6 is configured as an output by setting it to 0 in the TRISC register. So TRISC is a data direction register. Since we have connected our LCD to port B, I am setting the port B as an output port. So if I put 0, the corresponding pin will be configured as output, 1 it will be configured as input. Then I initialize the LCD, clear the registers in the LCD. We are going to set the cursor to be in off state. Then in the 1,1, first row, first position, I am going to put temperature. And in second row, first position, I am going to put received. And I need to display it for some 2 seconds. After 2 seconds, I am going to clear the display. Then I try to initialize the UART communication. So in the transmitter side, I have initialized the UART with 9600 baud rate. So the same baud rate should be used in the receiver side also. So UART underscore init 9600 baud rate. Wait for some time for the UART to get initialized. Then in a while loop, I am going to receive the data one by one. So we are sending 2 data. For example, the room temperature is 32. We will be sending 3 and 2. So I am going to receive this 2 data. So I use a for loop, I equal to 0, I less than 2. So I equal to 0 and I equal to 1 will be taken. And I am going to check whether the data is received using this function called as UART1 data ready. If the data is received, I read the data, put it onto the array. So we check whether the data is received using this UART1 data ready function. Once data is received, we read the data, put it onto the array. So like this, I try to get both the datas. Once my I value becomes 1, I try to set it to 0 because I don't want my I to get incremented subsequently. So I require only two datas. So as soon as I receive I equal to 0, I equal to 1, then I am going to reset the value again to 0. Once I receive the two datas, I am trying to put it onto the LCD. So first, in the first row, first position, I am going to put temperature. In the second row, first position, I am going to put temp equal to. Then I put the received data. So the received data is put using LCD underscore character underscore CP. So receive of 0 goes to the subsequent position and receive of 1 comes to the next position. So we are putting the two data which we have received from the transmitter side onto the LCD. Then I am going to put a space, and then after space I am going to put it as C to indicate it is measured in centigrade. So the display will be there for 1 second, and then again it will go and try to receive the data from your UART. Once the data is received, we try to put it onto the LCD. So this is the receiver part, where we try to receive the data using UART and display it on the LCD. Now let us compile the program. Now let us go and put this hexadecimal file related to transmitter and receiver onto our hardware. So let me select the transmitter controller, right click on it, edit properties, select the program file. So the program file, here you can see two X files have been created, microcontroller transmitter, microcontroller receiver. So this is the transmitter side, so I am going to put the X file of your microcontroller transmitter. Then set the processor clock frequency to be 20 MHz. Press OK. Same way receiver side, I need to put it the X file. So select the X file. Here I am going to select the receiver side X file. And again set the oscillator frequency to be 20 MHz. Press OK. So now the X files have been imported onto your transmitter microcontroller and receiver microcontroller. Now let us check the output of our program. When I press the play button, see it shows temperature received. Then it shows 29 degrees. So here you can see in LM35 it is 29 degrees. So here in the receiving side it shows 29 degrees. So when I start increasing the temperature, you can see there is a change here, 30 degrees centigrade. Same way as I start increasing, you can see in the receiving side the temperature is varying. If I start decreasing the value, again you can visualize it gets changed on the receiving side. So here what we have done, we have measured the LM35 on one side, then transmit the data using UART protocol, and on the receiving side we try to see the measured data. Thanks for watching. Please subscribe for more technical learning. Thank you.